for our computer system class is an implementation of a CPU scheduling algorithm called Heft. Heft stands for Heterogeneous Earliest Finish Time, which is an insertion based policy that minimizes finish times of the tasks that are to be scheduled on a set of heterogeneous processors. Heterogeneous processors are mainly processors that have different properties, and this situation generally lives on networks where there are different machines involved in task scheduling. So our system can be represented using a DAG and a computation cost table. As you can see on the left side of the screen, there's a DAG. Each node is a task, and each edge is a communication cost uh, between the two tasks. So if processor 1 was scheduled on one processor and processor 3 was scheduled on some other processor, there would be a communication cost incurred for that scheduling. And there is a computation cost table which says that each row in this table gives you the computation cost for a task on one of the processors. So if task 1 is scheduled on processor P1, there would be a computation cost of 14. So our algorithm takes two inputs. One is the two numbers on the top tell you the number of tasks that are in the system, and the second number tells you the number of processors in the system. Then there is an n by m matrix, which is the computation cost table here, and then there is an adjacency matrix at the end, which represents the DAG in the system. So the heterogeneous earliest finish time algorithm mainly has two parts. The first part is scheduling, sorting the tasks using an upper rank. Upper rank is a recursive formula that first calculates the upper ranks of the task of the successor of a task, and then after it computes and the upper ranks of each task, it sorts it in a decreasing order. So what this ensures is that once you have uh, sorted it using the upper ranks, the DAG would be topologically sorted, which means the edges would go in one direction. So when you start computing ESTs and EFT, which is the earliest finish time and the earliest start time of a process on a processor, that would uh, guarantee you to get the upper ranks of processors that are predecessor of a task, since it has been topologically sorted. So once you have the upper ranks, you topologically sorted, pick up the task from the list, and then compute the EST for it uh, on one of the processors, and then uh, you do this for each processor and try to maximize that first, and then you minimize the EFT, which is just the computation plus the ESTs. Once you've done that, it tries to minimize the EFT of each processor while scheduling it on a processor. Um, so uh, we have we have all the code in this repository here. So you can simply clone this repository here, and I've already cloned it in my local system. So what you need to do here is just run the two Python files provided. So you can compile the program using the compile Python file, and once that's done, you can run the uh, program using the run Python file. It will run the algorithm on two DAGs, which is provided in the example folder. You can go through the documentation of the generator to generate your own DAG and run it on your own DAG that has been created by the generator. Thanks.